we are going to move on to the last section of chapter 6. We are solving systems of inequalities by graphing. You have a small sheet of paper that we are going to use to take notes on to start. And I'll give you another sheet here in just a minute. You should also have an iPad that we're using Desmos on. A couple of markers for shading. Okay, so here in this sheet of paper, this is something I would want you to do nicely. We're going to keep it in our notes as something that for you to look back on as you're working these problems later. You'll have a good example to look back on. So here when we're looking at this paper, let's talk about the steps that we're going to have to go through. Anytime you're graphing, whether it be a linear inequality or an equation, what form do we like for our equations to be in? You got it. What slope-intercept form. So here in this first box, number 1, I'm going to write each inequality into slope-intercept form. Got it written up here. Write or put each inequality into slope-intercept form. Remember that's y equals mx plus b. We're going to be graphing today, so it's important that we have our inequalities in this form. Once we've got our equation or our inequality in the slope-intercept form, we're going to graph it. So in box number 2, write graph each line. And remember to graph, we always start with our y-intercept. We put a dot on our graph where the y-intercept is, and then we rise and run using our slope. Now this time when we're graphing, we're going to have to take note whether we are using a dash or a solid line, and we'll talk about when to use what type of line here in a second. Hopefully you remember. They tell you to come back. Huh? They tell you to come back.
I told him that I was showing how Mr. Watson that I couldn't be in the group, so.
Okay. And then once we've got our line graphed, we use a dotted or solid line. We're going to shade. And if you remember back to when we graphed linear inequalities, we tested a point. What point did we test? Remember? 0, 0. That's the point we take because it was easy to calculate. That's really the only reason we picked it. Sometimes we can't use 0, 0. If our line would happen to go through 0, 0, we'd have to pick a different point. So what I'm going to do next is, well, let's talk about dash versus solid line. Hopefully you remember this. We've done this, at least graphing a little bit like this before. We're going to use a solid line if we have the symbols of less than or equal to or greater than or equal to. We'll use a dashed line if it's less than or if it is greater than. Down here below where it says dashed line, I've got a couple of inequalities. If you would write down those 2 inequalities on your paper, we're actually going to graph those 2 next. We're writing down the 2 inequalities that are below the box that has dashed line in it. 2x plus y is greater than or equal to 2. X plus y is less than 2. In order to graph these lines, we're going to have to make sure our inequalities are in slope-intercept form. So let's look at the first inequality. Let's call this one our first inequality. What could I do to put that into slope-intercept form?
Subtract 2x.
Good. Subtract 2x. Move 2x to the right side. So we have y is greater than or equal to negative 2x plus 2. Now that it's in slope-intercept form, we should be able to graph this line. Hopefully you guys remember how to do some graphing. What's our y-intercept?
2.
Positive 2 is our y-intercept. So on the y-axis, put a dot at 2. the number in front of x, that's our slope. And we always like to make slope a fraction, so I'm going to make it -2/1. So the -2 is going to tell me I'm going to go down 2, and the positive 1 says I'll go right 1. Down 2 and right 1. Down 2 and right 1. If you prefer to have a ruler to graph with, you can grab one. I can wait for you. Everybody get a ruler that needs one and wants one? Okay, make sure you extend your graph. Let's go ahead and make it a good solid graph. We're going to put our points all the way across here. Will we use a dash or a solid line? Solid. And how do I know it's solid? It's equal to. It's greater than or equal to. So take your ruler, if you would, and draw a solid line through those points. So I've taken care of step 1, 2, and 3. Now I'm ready to shade in step 4. We need to test a point. What point did we say we like to test? 0, 0. So put a dot at 0, 0 on your graph, please. We're going to put 0, 0 into our original inequality to see if it's true or false. Do you remember, do we shade the true or the false side? The true side. So let's test 0, 0. I'm putting it in for x and I'm putting it in for y, my original problem. 2 times 0 is 0, and 0 plus 0 is 0. Is 0 greater than or equal to 2? That's false. It's false. So the side was 0, 0. This side right here is the false side. Which side do I shade? The other side, the right side. So take one of your markers, if you would, and shade in on the right side. And I would shade lightly. Shade real hard. That pretty well takes care of that inequality. Let's go ahead and graph the second inequality. Actually, before we do that, if I ask you for the solutions for this graph, where would you tell me the solutions are? Where are the solutions for right now, for the inequality that I've graphed? Where are the solutions? What is a solution? Was 0, 0 a solution?
Yeah.
No. Why not? Did it work when I put it into my inequality? No, 0, 0 did not work, so it was not a solution. What if I was to test something over here in the green area, the shaded area? Would that be a solution?
Yeah.
Yes. That's why we shade. Every single ordered pair in this green shaded area or a point on this particular line is going to be a solution. Any point in the green area, green shaded area, or on our line is going to be a solution. So if I ask you where are the solutions, where would you tell me? In that green shaded area. So let's graph the second inequality. This time we have x plus y is less than 2. It's not in slope-intercept form. What can we do to put it in slope-intercept form? Right, subtract x. So we have y is less than negative x plus 2. Let's go ahead and graph. What's our y-intercept? What's b? Positive 2. So we'll put a dot at 2 on our y-axis, which is right there. The slope is negative 1, or negative 1 over 1. So I'm going to go down 1 and right 1. Down 1 and right 1. You go up 1 and left 1. This time we'll use a dash or a solid line on our graph. A dash. And what again tells us to use a dashed line? Yeah, that inequality symbol, less than. It's not equal to. It's not included. So it's going to be a dashed line. Okay, so now we need to test a point. We again can test 0, 0. The only time we can't use 0, 0 is if our line happened to go through 0, 0. So then just pick something else. So let's pick 0, 0. Test that point. I'm putting it into the original inequality. 0 plus 0 is less than 2. Is 0 plus 0 0? Is 0 less than 2? That's true. So what does that mean about 0, 0? It's true, so what does that mean? It is, it's a solution. So let's shade the side with 0, 0. It's going to be the bottom half of this graph. Now I will caution you guys, since we are using markers, if you do choose to shade with marker instead of a pencil, and you make a mistake on your homework or test or quiz, anything like that, I am going to ask you to completely regraph. I don't want any crossing out and doing something. I need you to completely start over. Use a pencil, just erase it. No big deal.
What color is that? The dark green shaded in the upper cross? Like we used to keep it down a little bit.
Okay, so the blue shaded area, those points are solutions for this inequality, right? They're answers that make it true. They're ordered pairs that make that inequality true. Anything in this blue shaded area right here is going to work for that second inequality. So what if I said, where are the solutions for the system of inequality? The what? The green and blue area. I'm kind of blended together. Right here, this little triangular region right here. Those are my answers. Any point, any ordered pair in that triangle area right here is going to work for both of the inequalities. And that's what I'm trying to find today. I'm trying to find all the points that work for both of those inequalities. We could never name all those points. So the best way to represent our answer is with a graph. There's nothing to write down. We don't care where necessarily where the lines intersect, although we would know that thing. But instead, I want to know where the shadings overlap, because all those points are solutions. I want you to hang on to this. This is going to be something we're going to tape into our notebooks, and we'll do that at the end of the hour. We're going to go ahead and look at some more problems now. I've got a handout for you. We're going to do these together. Before we go ahead and look at some of the other problems, I want you to open Desmos real quick. Some of them. Did I not pick up homework from anybody's desk? Go ahead and open Desmos if you would. Carly, I'm going to have you do my screen up here. Let me go ahead and swipe up and set up. Here's good. Carly is already in. She's already got it graphed. Let's compare Carly's graph. We don't have to do it by hand this time. We'll do it here in just a minute. I'll let you guys have the opportunity to do it. Looking at this decimal, does that look like what we did by hand?
Yeah.
Now keep in mind, depending on how it's zoomed in, zoomed out, it may be distorted slightly from what you have on paper, but this one looks pretty good. It should go ahead and give you a dashed and solid line, which it does. Easy to see what we've got going on here. For dashed and solid, and this region right here is our solution. Thank you, Carly. You can swipe up and turn off mirroring. Remember, decimals is an excellent resource to check yourself, but don't just get reliant on it and use it every time, because you won't always have that option. Alright, let's look at the handout that I just gave you. Look at example 1 with me, please. Example 1, these inequalities are already in slope-intercept form, so they shouldn't be a big deal to graph. For the first inequality, what is our y-intercept? Lane, what's our y-intercept? Very good, 1. I'm looking at the first inequality right here. The y-intercept is at 1, so if you would, please put a dot at 1 on the y-axis. And our slope here is what, Delaney? -2. So I can make that -2/1 to help me graph it, if that works for you. So I'm going to go down 2 and write 1. Down 2 and write 1. Will we use a dash or a solid line?
Yeah.
A dash. And how do I know that it's dashed? Yeah, it doesn't have a line underneath. It's just greater than. So let's use a dashed line. So now we need to test a point because we need to shade one side of the line or the other. So let's test a point. Let's test 0, 0. Our line doesn't go through 0, 0, so we're fine. It's close. It doesn't go through it. So let's use 0, 0. I'm going to put into the original problem. Is 0 greater than? -2 times 0 is 0 plus 1. So is 0 greater than 1? That's false. So the side was 0, 0. That side is false. Let's shade the other side, which is our true side. Let's graph the second inequality. What is the y-intercept here, Landon? Of the second inequality, what's the y-intercept?
3.
3, very good. Dot at 3 on the y-axis. What is our slope, Olivia? 1. The number in front of x is our slope. Remember, we can make that 1 over 1. Slope is rise over run. So from this point that we plotted at 3, we'll rise 1, run 1. Rise 1, run 1. Could have also went down 1 and left 1. Will we use a dash or a solid line for this graph? Solid. So once again, let's test an ordered pair so we know which side of the line to shade. I'm going to test 0, 0. 0 is less than or equal to 1 times 0 is 0 plus 3. And 0 plus 3 is 3. Is that true? Is 0 less than or equal to 3? Yes, it is. So let's shade the side with 0, 0. So this time it will be the bottom or the right side of the graph. Remember, when we're graphing, we're looking for the region that has both colors shaded. that's our solution. We could never name all of the solutions, so instead a graph is what we use to represent our solutions. Our solutions are all the ordered pairs, every single ordered pair that's within my green and brown shaded region. Real quick, when you've got this graph by hand, I want you to open Desmos and do it on there. Let's see what this is going to look like. We do it on Desmos. And it might be something that as you're working your homework problems today, you want to graph one of your lines on Desmos. Graph it by hand and then graph it on Desmos, and then graph the other by hand and then graph it on Desmos. That way you make sure you've got it right. And of course, always wait for the inside. Here's Landon's graph. Does your graph look similar to his? Does your graph on paper look like his? Remember, depending on how zoomed in or zoomed out your graph is on Desmos, it may look a little distorted. Question?
No.
Alright, I would like to look at one more by hand, if you would. Look at example number 2. Example number 2 is a little bit different because of this first inequality. That's the main one I want to make sure that we're able to graph. If it was a y equals graph, what would that line look like? Good, it would be a horizontal line. What if it was an x equals graph? What would that look like?
Vertical.
A vertical line. Very good. You guys remember that. So let's go ahead and graph this horizontal line at 3. So it's crossing our y-axis at 3. Will this be a dash or a solid line at 3? Solid. We can still test 0, 0, even if there's not an x value to sub into. We're just going to put 0 in for y. So we'll say 0 is less than or equal to 3. Is that true?
Yep.
Sure is. So we're going to shade the side with 0, 0. 0, 0 was true. Is that in slope-intercept form?
No.
Nope. Let's put it in slope-intercept form. What would you do first? I would subtract x. Yeah.
Sorry.
You're okay. So y is greater than or equal to negative x plus 1. What is the y-intercept then? Positive 1. And the slope? Negative 1. Negative 1. Down 1, right 1. Down 1, right 1. Also go upward and left 1. Will we use a dash or a solid line here?
Solid.
Solid. Let's test 0, 0. I always recommend putting it into the original problem just in case you forgot to flip your inequality symbol. That won't affect you. Let's put it into the original problem. 0 plus 0 is greater than or equal to 1. Is 0 greater than or equal to 1? That's false. So we don't want to shade the side with 0, 0 this time. Shade the other side. our solutions are points within the region that is shaded in green and brown. Can't list all those solutions, so we're using our graph to represent them. Real quick, I want you to graph this on Desmos so you can see what it looks like. Oops. Okay, we're graphing on Desmos. Let's check this graph out. Just tap out of the screen. Here's Natalie's graph. Does ours look similar to hers? It should. It should. Any questions on graphing using Desmos or by hand here? The big thing you gotta remember is to put it in self-intercept form. You can go ahead and get out of that, Natalie, see what you want in. The biggest thing to remember is to make sure your inequalities are in self-intercept form. Remember to test the point 0, 0 so you know which side to take. How do we know when to use a dash or a solid line?
Whether it's equal to or not.
If it's equal to, what are we going to use, Colin?
Solid line.
A solid. If it's less than or equal to or greater than or equal to, we'll use a solid. Landon, when are we going to use a dash?
Whatever it's not equal to.
Do that. When it's not equal to, less than or greater than. And what about an answer? Do we need to write something down for our answer? No, our graph is our answer. That shaded region where the graphs overlap is your answer. Remember, if you do make a mistake, if you're using markers or pens or something and you make a mistake, I would like for you to completely regraph. If you want to take an extra sheet of homework, graph paper, you think you might need it, you're welcome to do that. I do want you to completely start over if you do make a mistake. You can always cut it out and paste it onto your homework sheet. All right, homework is going to be out of the book. I'll go ahead and pass out that assignment. Did I forget to pick up anybody else's homework paper? Gosh, I thought I got it and messed up. These homework papers that I get for everyone. Yes.